So we were talking about the VPC, right? So yesterday we saw what are some of the components in the VPC, okay? And the IP addressing part side, right? So we will choose a location, right? And we will what do you say? Sorry, VPC, okay? And we will go ahead. We will start creating the VPC. So I'll choose the Canada location, right? So you can do the use the US East itself, no problem, because you will not have anything. I'm using the other locations for the other classes and other stuff. I will pick some location which I have never used. Okay, so probably in Canada I don't have anything. Okay, okay. So we will use Canada Central. Okay. So yesterday we saw what are some of the components in the VPC. So basically you have the VPC, and then VPC you split up into smaller networks called the subnets, right? You can have multiple subnets that you have, right? Subnets, and whatever infrastructure you create, right? Your servers, your databases, they are actually located inside the subnet, right? And then you have other components like the route table and the router, internet gateway, all that stuff. Okay? So the next concept we are going to see is default VPC. Okay? What is a default VPC? So for everybody who creates an AWS account, right? So in all AWS accounts, when you create your account, AWS provides one VPC per region, and inside that VPC, right, there will be one subnet per availability zone, which is provided by AWS. This is already there in your account. You don't have to create it. Okay? To make your work easier, especially for people who are just starting off, right, with AWS, right? So maybe, I mean, they want to create a server or something, right? Okay, so they don't have to worry about creating the network. Okay? But practically speaking, not many people really use the default VPC, right? So it will be there. So if you open your AWS account and see, you go to any region, right? You go to the VPC under services, okay? You go to under VPC services, you will see one VPC over there. In any region you go to Canada or you go to US or India or Mumbai, you will see one VPC that is already there for you. Okay, so that VPC will have the same values for everybody. Okay, so like I said, you yourself can have two VPCs with the same CIDR, right? Because the VPCs are isolated from each other. So it is not that you should have two unique CIDRs for your VPCs, right? Practically, you yourself can have two VPCs with the same CIDR in the same region because they are isolated from each other. Okay, so everybody, any AWS account you take, right, it will have usually one VPC per region. You go to Canada or you go to Ireland or Frankfurt, anywhere you go. So let me go to Frankfurt. There also you will see the same thing. There will be one VPC with 172.31.00.16, right? 172.31.00.16, right? Any region you go. And what they have done is they have split that VPC into one subnet per availability zone. In Canada, we have three availability zones, A, B, and D, right? So there will be one subnet per availability zone. If you take your US East and C, there will be 6 subnets. That is, they have split that VPC into 6 subnets, 6 approximately equal subnets, right? This is already there for you. We call this the default VPC. That is the VPC provided by AWS. So under the default column, it will say yes, right? Under the default, don't look at this. The meaning of this is different, right? Under default, you will see yes. So this is the VPC provided by AWS in your account in every region. So there will be only one default VPC. There cannot be two default VPCs, right? This is the VPC provided by AWS with this type of configuration. One VPC per region, one subnet per availability zone. It will have one internet gateway, right? It will have one route table, one NACL, one security group, right? But basically, we say one VPC per region with one subnet per availability zone, and it is provided by AWS. That is called the default VPC. Okay. Anything else you create, right? Any other VPC that you create is called a non-default VPC. Okay. There can be only one default VPC or no default VPC. If you don't want the default VPC, you can remove it. Right? It is just already provided out of the box for you. Okay, so what is 172.31.00.16? Right. 172.31.00.16. So what is the meaning of that? The possible IPs are 172.31.0.0 to 172.31.255.255. That is 65,536 IPs. And this they have split up into smaller subnets, right? And what is each subnet that they do? They do 172.31.16, sorry, 172.31.0.20, 172.31.16.20, 172.31.32.20. So if you have more, it will be like 48.0/20. So you can put this and see, right? 172.31.16.0 you can put. So it is within that range. Okay. So the 172.31 range is this, right? Right. So for the default VPC, you have something like this, right? So the IP can be from, what do you say, 0.0 to 255.255, right? So within this, you can split up into smaller subnets. So they are providing 3 subnets, one per availability zone. Some more IPs are left, right? So whatever they provide, it will have around 4,000 IPs per subnet, 4,091 IPs per subnet. Okay. If you want, you can create more because some more IPs are left, right? We have used only 4 into 3, 12,000 IPs we have used. We have another 50,000 IPs around, right? 52,000 IPs are there. You can create more subnets if you want. Similarly, you will have one route table. You will have one route table, and it is called the main route table. You will have one internet gateway. You will not have any other stuff. You can take a look, right? All these you will not have anything. You will have one access control list, and you will have one security group. This is already be in your account. You will not have any other stuff. Okay. This is called the default VPC. So what is the other thing? Then the non-default VPC. Anything we create is called non-default VPC. Okay. So if you want to look at the diagram, how it looks, right? The default VPC looks like something like this, right? Because you need a diagram to understand the network, right? So the default VPC looks something like this. In any region, right, you will have one subnet per availability zone. You will not have the instances. I don't know why they put the instance, right? Because there are no instances. It is just empty. This is not there, right? They have just created the network and given you, right? So now we can come and we can start creating our machines over here, right? So we will not use the default VPC, right? Because we need to know how to create our own VPC, right? So you can go ahead and you can remove the default VPC if you don't want it, or you can just keep it aside because it is anyway free, right? So I can go and just say, go to actions and say delete the VPC because I'm not using this in Canada. I just want to start from a clean slate so that it will be easier for you to understand, right? So I will delete this VPC. So it will remove all the other components which are part of that VPC, provided you're not using anything. If you use anything, it will give you an error saying that it is in use. Okay. So now we have removed the VPC. So all the subnets and everything also is cleaned up. So we don't have anything. Okay. So now, for example, if you want the default VPC again, you can simply go to actions and say create default VPC. It will create the same thing, right? Whatever I said, right? With default subnet availability zone, internet gateway, all this will be automatically created. Same CIDR, right? Same subnets. Again, it will be recreated in less than a minute. Okay. So if you don't want, we can remove it, or you can just keep it aside without using it. Okay. So there can be only one default VPC, or you can remove it. Anything that you create will not be default. It's a non-default VPC. Okay. So now we will create our own VPC, right? We saw all this yesterday, right? What are some of the components in the VPC and all that stuff, right? IP addressing, right? How many VPCs we will have, right? How many subnets we need to have, all that stuff we saw yesterday. So we will go ahead and we will create the actual VPC now and the other components. Okay. So to create our VPC, we need to, what do you say, know the architecture first. You don't simply start creating it without the diagram. Okay. So we should know what we want. Okay. So say for example, we are creating the VPC, right? We want to start putting our infrastructure. So probably the first thing you will be creating in AWS is the VPC, because pretty much any other service apart from S3, it will need some type of a VPC, a lot of services, right? So which location you are going to choose? So for us, we are saying Canada. Okay. Then what is the VPC's CIDR that we are going to use? What is the IP range that we want to use? Then what are the subnets that we want to use, right? How do we want to split this VPC up initially, right? How do we want to split this VPCs, right? Okay, so now let us say I want two subnets. I'll show you the diagram also. First, I'm just making a list, right? So don't worry what is a private subnet, what is a public subnet. I will come back to that. Just think of it as we are creating two subnets. Right. We are going to use Canada. We are going to create a VPC with some CID. Right. We are going to have a private subnet, public subnet. We will have a internet gateway. We will have something called a NAT gateway. So again, NAT gateway also, don't worry about it for now. We will come back to that. Right. So our architecture will be something like this. I want to create something like this. That is, I want to create a VPC with two subnets, right? And where are those subnets going to be located? I told you your subnets will be in the availability zone, right? The VPC will be in the region, right, which is Canada, and inside that region, the subnets which you create will be in one availability zone. So for private subnet, which availability zone you want to use? Public subnet. So we have to make sure we have all the values, right? So I want to create the private subnet in, say for example, here what have they used according to our diagram. I want the private subnet in availability zone. Sorry. A, and maybe the public subnet in availability zone B. So let us say my architecture is something like this. And what are the, the values that I want to use? So if you look at this diagram, right? So there are two subnets, but both are in the same availability zone. I will just make a small change. We will put it in two different availability zones. Okay. You can have multiple subnets in the same availability zone, but simply just to make use of multiple availability zones, I will just modify this diagram, right? And let us put the public subnet in, sorry, availability zone B. Here it is availability zone A, right? So we will create this. So we have the CIDRs. Okay. Now for the VPC, I want to use the CIDR 10.0.0.16. So what is the meaning of that? Right? 10.0.0.16 means I can have 65,535 IPs. Right? And my IP range is this 10.0.0.0 to 10.0.255 for my VPC. And I'm going to split it up into two subnets. Right? One is public subnet, which is going to be 10.0.0.24, and one is called a private subnet, which is going to be 10.0.10.24. So 10.0.0.24 means these bits will be constant. This last one will change between 0 to 255, right? 0 to 255. Here, same thing. First three will be constant. The last will change between 0 to 255. So each subnet of mine can have, say, practically, I mean, on paper, it can have 256 IPs, right? But because AWS, I told you, it uses the first four IPs and the last IP for some special purpose, right? So whatever subnet you create, right, the first four IPs, that is 0, 1, 2, 3, and in this case, right, 255, right, is used for some special purpose. We saw it yesterday, right? 0 is the network address, 1 is the router, 2 is the DNS, 3 is it is reserved for future use, 255 is broadcast. So you can't use these four IPs. So practically you have 251 usable IPs. That is, you can have up to 251 devices in each subnet. Okay, right? So we have the values for that. So we are making a note of all those values, and then we have some additional stuff, right? We are going to have a internet gateway, right? We will create all these things, right? We will have the internet gateway, the route tables, multiple route tables. This is the final diagram, right? And then we will create some machine over here, some machine over here, and see how the traffic is flowing. Because without the machine, you cannot see the traffic flow. Again, to create the machine, you should know EC2. So don't worry about that. I'll show you. Then if you're comfortable, you can create the machines, or you can just practice by creating the VPCs. The next topic will be EC2 instances. Then you can create the virtual machines. Okay, because one thing depends on the other. Okay, so we will have internet gateway, route table, something called the NAT gateway, right? And all this stuff we need to create, right? So let us go and create. So like I told you, how which CIDR to choose for the VPC, how much to choose for the subnet, you have to choose it wisely, right? Don't create a VPC that is very big or that is very small. Then you will not have enough IPs, or you will have too many IPs, and you may not be able to use the same range elsewhere, right? So we discussed that yesterday. So if you want some number of IPs, you choose something that is closest to that, assuming factoring in some expansion in future. Suppose you need 200 machines, maybe create something like this, right? with 255 subnet. So 10.0.0.16 is a very big VPC, 65,000. Maybe you don't need so big, right? Maybe for you 10.0.0/24 itself might be enough. That is 255 IPs itself might be enough. Maybe you don't have more than 251 servers. Maybe you have only 100 servers. So maybe /24 is enough, right? You don't have to create /16 because all this is free. Whether you create 16 or 24, there is no difference either in performance or in cost or anything. But you are just having too many excess IPs, which could be used in another VPC, right? Instead of creating a VPC like 1 to 65,536 IPs, when you need only say 100 IPs, then you might as well create 1 to 255 for the VPC, right? Because the remaining, right, 250, sorry, I should not say 256, but I'm just telling the number of IPs. This is the number of IPs, right? So if you want only 255 IPs, 100 IPs, then maybe you can create like 1 to 255, and the remaining, right, you can create other VPCs. So there will not be any overlap, right? You get the point. So you can create another VPC with so many IPs, so that there will not be overlap. So don't try to create something that is very big, right? Okay. But here in this example we are doing, right? So anyway, whatever is it, the process is how to create it. The numbers we can choose according to our environment, right? So how do we go ahead and create this, right? We have all our the values with us, right? So always it is better to have the architecture diagram and then implement it. Don't do it the other way around. Okay. So let us go and create them, right? We have noted it down here. So how do you create the VPC? So you go here, go to VPCs and say create VPC. Now we see we don't have anything. We don't have any subnets, no route tables, no access control lists, no security groups. We don't have any of these things. Okay. So the first step is to say create VPC, right? And you give the VPC a name. So let us say we are creating this VPC for the dev environment, right? So we will call it the dev VPC. You can give whatever name you want, right? So we are creating the dev VPC in Canada. Okay. And then what is the CIDR block for it? What is the CIDR block we are going to use? 10.0.0.0.16, right? So you put that. So you have to specify all IPs in CIDR. Even if it is a single IP or if it is a range, you have to specify in the CIDR. If you don't specify in the CIDR, you will get an error, right? You will get an error. We are doing 10.0.0.16. We are not using any IPv6 and leave this at default. We will come back to this later, right? And say create. Simple, your VPC is created. Okay. Your VPC is created, right? It will have a VPC ID, right? It's CIDR, right? And then if you see default, it will say no. Whatever you create is not default VPC. Only what AWS provides is default VPC. Anything else is non-default VPC, right? So when you create a VPC, what are the other stuff which is created along with it? Okay. If you look at the default VPC, what it came with? It came with one subnet per availability zone, one internet gateway, one security group, one access control list. Default VPC. But the VPC which you create, what does it come with? Okay, VPC is created. What is VPC? It is simply the boundary you are defining. In Canada, I am creating a private network with this range. You are just marking the boundary. Okay. Then if you go to the subnets and see, you will not have any subnets. All these you have to create. Default VPC, it is there for you already out of the box. Here you have to create, right? So what comes with the VPC? When you say create VPC, what are the stuff that comes? Basically, you will get one route table, right? What is the route table? It is like the map which says how the traffic has to flow. Okay. When you create a VPC, right, you get only the VPC, the boundary, and you get a route table which is called the main route table. So whenever you create a VPC, a route table is automatically created for it. Route table is something which specifies the routes or the path the traffic has to take in your VPC or out of your VPC, how the traffic has to flow. So it is called the main route table, and there will be only one main route table. Anything else that you create are the custom route tables, right? The main route table is the route table that comes along with your VPC. You cannot remove it, right? You cannot remove it. Okay, you cannot remove this main route table. You can create additional route tables, right? But when you create a VPC, the main route table comes along with it. Then if you go to internet gateways, you will not see anything, right? The default VPC will have an internet gateway. Here you will not have any internet gateway. And similarly, you will not have any other stuff except for one access control list and one security group. This is the default security group and the default ACL, right? This is the default ACL and you get a default security group, right? Which comes along with the VPC. So along with the VPC, basically you get only one route table and one security group and access control list. You don't get anything else when you create it, right? So what is the next step? We need to create the subnets, right? According to our diagram, we need to create one subnet called the public subnet, one subnet called the private subnet. Okay. So what is a public subnet? What is a private subnet? I will explain, right? After we create it. So right. So we will just say we need two subnets. The private subnet will have the app servers, or you can call the app subnet, right? Only for this example, I am saying private public. Nobody will really name it private and public. They will give it some name, right? Like I told you, why do you have different subnets? So that you can split up what you say, the different layers in your architecture into groups. So you have app servers like Tomcat or DB servers, right? So you want them to be grouped together. So here we are having two subnets. Let us say the private is used for the, should be the other way around, right? Practically speaking, right? I will put the DB servers in the private subnet, right? And I will put the app servers in the public subnet. In real time, probably they will call it app subnet and DB subnet, right? Okay. So we need to create two subnets. So let us go and create that. So how do you do that? You go to the subnets. You cannot go inside the VPC. You cannot click over here and go inside the VPC. Currently the GUI is not like that, right? Don't expect to click here, go inside the VPC and then create the subnet. It is not like that. You have to come here and create. You come here, come to subnets and create subnet. So what is the name that we want to give? We want to call our subnet as public subnet and private subnet, or app subnet, DB subnet. Okay. So I'm going to create the the private subnet first, right? So I will just call it private subnet, right? Or like I said, in practical they might call it app subnet. So we'll just say private app subnet. Okay. Or let us just call it private, right? So maybe afterwards we will change it, right? And in which VPC you want to create the subnet, right? Where is the subnet located? Inside the VPC. If you have multiple VPCs, it will show you here. We have only one VPC, so it is showing me only that. Okay. So I'm saying create a private a subnet called a private subnet in this VPC and in which availability zone. If you don't specify the availability zone, it will choose anyone randomly. But no, according to our architecture, we want the private subnet in which availability zone? In A, right? We want to create a private subnet in availability zone A and the public subnet in availability zone B. And what is the CIDR for that? 10.0.10.24, right? We want to create the private subnet in A. And what is the CIDR for that? 10.0.10/24. Simple. And say create. So now we have created one subnet. Same step, create another subnet. We are going to call this public subnet or DB subnet, right? And again, which VPC you want to create? What is its CIDR? /24 and what availability zone? We are going to use B. for the public subnet according to our diagram, right? And say create. Okay. So we have created that. So if you want to look at the diagram, so right. So when you say create VPC, what is actually created? Only the boundary, like this. What you see in the diagram is what is created when you say create VPC. So in Canada, right, what it is doing, it is going and creating the boundary with the CIDR which you specified. The first thing that we did, right? It is spanning across all the availability zone. Now what I did, I came to one availability zone. I created one subnet over here, one subnet over here, right? I created, sorry, we have this, what is the, yeah, okay. So we created the private subnet in A. This is our private subnet. This is our public subnet. So far we have created this. Okay, first the VPC, then the private and the public subnet we have created. The main route table already comes with the VPC. Okay, so what is this main route table, right? What is the route table? It is going to show you how the traffic has to flow. Okay, so the route table, right, is there. We have the main route table and we have two subnets, right? We have two subnets. So whenever you create a subnet or whenever there is a subnet, it will be attached to a route table. Every subnet that you create will be attached to a route table. The route table is for what? It is for the subnet. Even though we say it is there in the VPC, the route table is for the subnet. That is because your machines will be in the subnet. So how their traffic has to flow is defined in the route table. So any subnet you create will have a route table. You can have multiple route tables also, which is what we are going to create. The main route table is there. It comes along with your VPC. So you can have multiple route tables, route table 1, route table 2. You can create, all this is free. So whenever you create a subnet, another subnet, if I say, I can attach it to this. We call it, it is attached to a route table. It is associated with a route table, right? Every subnet is associated with a route table. Only one route. It cannot be associated to two route tables, right? Each subnet will be associated to one route table. You cannot have a subnet without a route table, which is why you cannot remove the main route table, because whenever you create a subnet, right, by default it will associate itself to the main route table. Afterwards you can remove it and you can associate it with another route table if you want, right? So now we created two subnets, both of them will be associated with the main route table because we are not explicitly associating it initially, right? So both of them will be associated to the main route table. What is the meaning of that? That is, both the subnets will follow the rules given in the main route table for traffic. So if you don't want, then you can remove the association to the main route table and you can associate them to a different route table, right? Which is the reason why the main route table you can't remove, because whenever you create a subnet, it will first go and attach itself to it will associate itself with the main route table. So the main route table will be there. If you don't want, you don't have to use it. After it creates, you remove this attachment and then you attach it to, you associate it with a different route table. But the main route table will be there. You cannot remove it. Because tomorrow if somebody else comes and creates another subnet, it will automatically attach it to this. Okay, the normal behavior, which is why you cannot remove the main route table. Okay. 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 So remember, every subnet will be associated with a route table, with only one route table. This subnet cannot be associated to both the route tables. No. Okay. And the route table will have the routes. So it will say how the traffic has to flow. So when you look at the main route table, it will have only one route. It will say 0000. Sorry, it will say the VPC CIDR and local. So what is it saying? Any traffic going to this network. What is this network? 10.0.0.0.16. It is your VPC. It is local traffic. It is like you bought a router at home and you connected some machines. So these machines can talk to each other. It is the local network. They don't need to go anywhere outside, right? So, which is what is being created, right? The main route table has only the local route. That is, it defines that any traffic going to this network, that is going within your VPC, is local traffic. If you look at the main route table, which comes with your VPC, right, it will have that route. If you go to the routes, you will see there is only one route. That is, it is saying traffic going to this destination is local traffic. And then it is associated with both my subnets. It is, right, because we didn't explicitly associate it, it is automatically associated with the main route table. We created only the subnet, we didn't associate it explicitly, so it automatically associates itself with the main route table, right? So currently both my subnets are associated to the main route table. According to our diagram, so far what has happened is two subnets we have created and both are associated with the main route table. Okay, this is what has been created now. Okay, now the next concept is what is a public subnet, what is a private subnet, right? Whenever you create a subnet, it can either be a public subnet or private subnet. Now let us say this one which we called private, we are using it for the app, for the DB servers, right? And the public subnet we are maybe using for the app servers. Like I said, practically nobody will name them private and public. Just for the sake of example, so that you can understand, I have named it private and public. But these are simply technical terms. It is not the name of the subnet, but a technical term. What is a public subnet? What is a private subnet? Right? So a private subnet, right, is a subnet, right, which is associated to a route table, right? A private subnet, a subnet becomes a private subnet if it is associated to a route table in which there is no route to the internet gateway. And a subnet becomes a public subnet if it is associated to a route table which has the route to the internet gateway. So it all depends on one rule in the route table. So currently if you see in this route table, I don't have any route to the internet gateway, right? In this route table, there is no route to the internet gateway. That is, you will see something like 0000/0 to IGW. You will see a rule like this, right? So now we don't have that rule. We don't have that rule. Okay, and now both the subnets are associated to this route table. So now technically both are still private subnets, even though we named one as the public, because in future it will become public. At present, both the subnets which we created are still private subnets technically. Don't worry about the name we have given just for our identification, but technically speaking, both our subnets are still private subnets because they are associated to a route table which does not have a route to the internet gateway, right? So what is an internet gateway? I told you it is a device which sits at the AWS boundary, right, which is attached to your VPC. So we will create an internet gateway and we will attach it to our VPC. So this internet gateway is a device which allows, which gives you a provision to send traffic to the outside world. Now we cannot send traffic to the outside world because there is no path. We have not yet created the internet gateway. So when we create an internet gateway and attach it to our VPC, right? So what we will do is for the public subnet, we will create a route table. We will create another route table, and here we will add the additional rule. We will say any traffic going anywhere else, that is 000 IGW, right? And then what we will do, whatever subnet we want to make public, we will associate it with our new route table. So we will remove this association and we will associate our subnet which has to be public subnet to this route table. Only then it becomes a public subnet. Okay, so if you see a route table, right, which has this rule, that is traffic going anywhere, that is outside, right, through the internet gateway, and you have a subnet which is associated with this route table, only then it becomes a public subnet. That is, the subnet has to be attached to a route table which has this rule. It only depends on this one rule, not on anything else. So what is the meaning of this is, the machines in this subnet, they can go outside to the internet, or traffic can from outside can reach these machines. Whereas the machines in the private subnet, they can technically, so far communicate only internally, only inside the VPC. They will not be able to go outside. Okay, that's what we mean by private and public, but we will be doing more configurations. Okay, so the machines in the private subnet are not exposed to the outside world. They can go to the outside world, but from outside traffic will not come to them directly. So why you want a public and a private subnet, right? Why are people going to create private subnets or public subnets? Because certain services like the DB servers, right, they don't need to be exposed to the outside world, because your DB server will talk to your app server. Let us say the app server is what the end users they connect to, right? Your Tomcat or Nginx or whatever, right? The end user is opening the service or the application. It hits the application or the web server. The DB is the backend. It does not need to be exposed to the outside world, right? So usually we keep stuff like the DB servers in the private subnet. Okay, so we will see. I will create the machine and show you the traffic flow. Then probably it will be more clear for you. But you have to understand what is a public subnet, what is a private subnet, right? The thing that defines whether it is a public or a private is the rule which you see in the route table and to which it is associated with, right? So a subnet becomes public if it is associated with a route table which has a route to the internet gateway. So we have not yet created the internet gateway, right? So currently our diagram is, we don't have all this. Currently our diagram looks like this. Both the subnets are associated to the main route table, and the main route table, it doesn't have any route to the internet gateway. So now technically both our subnets are still private. Even though I've named it public, it is not public. This is just in future, after we finish everything, this will become public, right? So if you look at our route table, it has only the local route, right? And both my subnets are associated with this automatically. Okay, the next step is, according to our architecture, we need the internet gateway. So let us go and create the internet. So this router you can't see, it is already created. When you create the VPC, the router is created. What we mean by the router is the routing tables. The router will follow the rules in the routing table. You cannot see or edit or manage the router. It is only the routing tables that you can manage, right? So now let us go and create the internet gateway. You say, so the internet gateway is again pretty straightforward. It does not have any configuration except that you give it a name. I will say dev IGW because it's in the dev VPC. Okay, and say create. It does not have any configuration, right? You create it and you attach it to the VPC. Simple. If you don't want, you detach it, right? You choose the VPC and you attach it. The internet gateway does not have any other settings, right? If you want, you create it, you attach it. If you don't want, you remove it. Finished. So each VPC can have only one internet gateway. You cannot have two internet gateways attached to your VPC. Right now, if I say create internet gateway, right, it will create, but it will not be attached to the VPC. If you try to attach it, it will not show you any VPC because your VPC already has an internet gateway. Either you have an internet gateway or you don't have. You cannot have two internet gateways for your VPC, for any VPC, right? Okay, so your VPC can or cannot have an internet gateway depending upon your architecture. We will see for what we need internet gateway when we see the traffic flow. Okay, so now I have created the internet gateway, right? It does not have any other settings, no rules or anything. It is simply a device which sits at the boundary, that is at the AWS end, and it is connected to your VPC, that is it is attached to your VPC, right? Okay, so we have created this internet gateway also. We have created a internet gateway. It is located over here at the AWS boundary and it is attached to your VPC, right? Okay, and what other stuff is there? Right, we have our internet gateway created, and then we have already one security group and one access control list comes. We will talk about this, right, also. So now let us make our subnets private and public. So currently both my subnets are private because both are attached to the main route table, and the main route table, it does not have a route to the internet gateway. Okay, so ideally don't modify the main route table, just leave it as it is. Okay, don't modify the main route. You can modify if you want, you can add more rules, but don't do that, right? Don't try to avoid that in real time. So we can create our own, what do you say, additional route tables, which is what we will be doing, right? We will create our route table called private route table, right? And we will create one route table called public route table. Okay, so currently both my subnets are private because they are associated to some route table which does not have the route to the internet gateway. It's not enough if the internet gateway is there. That rule has to be there to the internet gateway. So we will go ahead and create a route table. Let us go to route table and we will say create route table, and I will say public route table. And in which VPC you want to create? We have only one VPC, so we choose that and we say create. Okay, so now if you look at the public route table, the top one is the main route table. Let me just do that. This is what comes with the VPC, right? Now we have created public route table. It will also have only the local route. Whenever you create, the local route will be there. You cannot change it. Okay, so the local route will be there, and it is not associated to any subnet. We have just created it. It is simply sitting over there, right? These two subnets which we have, they are associated with the main route table, not with our route table, not with the one which we created. The route table is simply sitting. What we created is simply sitting. Same thing, we will create another route table called private route table. Inside our VPC. Right? So here also same, the private route table which we created, right? It will also have the local route and no subnets are associated with it. Okay. Now what I will do in the route table which we are going to associate to the public subnet, here I'm going to go to the routes and say edit routes, and I'm going to add the don't modify the local route. Okay, just leave it as it is. So now here I'm saying traffic going anywhere else, that is traffic going everywhere, it should go through the internet gateway. We have already created the internet gateway, so it is showing me that. And I'm saying save routes, right? So for one route table which we created, we have the local route, right? And then we are having 000/0 to IGW. But we have not yet associated any route table to this. We have just created the sorry, we have a local route in both, but in one route table I added the internet gateway route. So now if I want to make my subnet in availability zone be as public, what I need to do is I need to remove this association and I need to associate it with this. Only then it will become a public subnet. Currently both are associated with the main route table. So now what I need to do is I can go to the subnets, and whichever is going to be my public subnet, I know that because I have named it. While creating itself, I named it as this. This in future is going to become the public subnet, but now it is technically still a private subnet. So what I can do, I can choose this. I can go to the route table and say edit route table association. Currently it is associated to this route table 745B. What is 745B? It is the main route table. And what does the main route table have? It has only the local route. It does not have the route to the internet gateway. So I'm going to edit the route table association and associate it with my public route table. So what does the public route table have? It has a route to the internet gateway. So only when you do this, only when you attach a particular subnet to a particular route table which has this route. So if you see 000/0 to IGW, only then this subnet becomes a public subnet. Otherwise it is always a private subnet. It is purely based on this one rule. There might be other rules. Okay, but if you see this rule 0000 and IGW, that is 000 going through the IGW, that is the target is IGW, then it becomes a public subnet. Okay, so now my subnet called the public subnet has technically become a public subnet because it is associated to a route table which has a route to the internet gateway, right? The other subnet is still attached to the main route table, and the main route table there is no rule to the IGW, so the other subnet is a private subnet, which is what we wanted. Okay, so don't go and add the rule for IGW over here. If you add a rule for IGW here, then any subnet associated to this route table will become public. So to just be on the safer side, because what happens is whenever you create a subnet, what I told you, it will automatically be attached to the main route table. So automatically it will always be private. So like it is a good practice, so that if somebody creates a subnet and they don't change the association or whatever, it will remain private. It is safer. So ideally don't edit the main route table. You can if you want to, but ideally don't. Just leave it as it is and we create our own route tables and associate our VPCs to that, because we might need to edit our route tables. So now we have a private route table and it has the local route. So what I will do, I will not use the main route table. I will remove this association and I will associate my private subnet to this route table, to this private route table, so that we don't modify the main route table. We'll just leave it. So tomorrow if somebody creates another subnet, automatically it will be associated to this route table and it will remain private until you go and change its configuration. Right? So now what I will do is, for my private subnet, I will associate it with the second route table which we created. Right? So my second route table which we created is the private route table, right? And it has only the local route. So let us go to my subnets and my private subnet. Currently it is associated with the main route table. I will associate it with my private route table. Main route table, I'm just keeping it aside. Let it be there. I don't want to modify that. Right? So now I have associated it something like this. So if you look at our diagram, there would be a small change. So here the main route table itself is being edited, but we are not going to do that. main route table we will keep aside. We will create our own route table called private. This is our public route table. We don't have this rule yet. This is not yet there. Don't worry about this. Okay. So now we have created all this, right? We have created a public subnet, private subnet. It is a public subnet because it is associated to some route table which has this rule. Thus, the other subnet is associated to a route table which does not have the IGW rule. So it is a private subnet. Okay. So we have created this. We have created the internet gateway. We have not yet created the NAT gateway. We will come back to it. We have not yet created the NAT gateway or the instances. Right? We have not yet created the NAT gateway or the instances. Okay. The main route table, it just has the local route. So we are not going to modify it. We just keep it aside. Right? So that somebody else creates another subnet tomorrow, it will automatically become private by default. Okay. So that private subnet, public subnet, it depends upon the rule in the route table and to which it is associated. So like I said, what type of machines you will keep in a private subnet? It is mostly like DB servers, but nowadays pretty much a lot of people, they put everything in the private subnet and they route the traffic accordingly. Right? So ideally the services which you don't want to expose to the outside world will be in the private subnet, like DB service, DB servers, some backend servers with which the end users don't interact directly, right? So those type of things. So maybe your Tomcat, Nginx, Apache, these things which are what you say, which face the end user, right? They can be in the public subnet, right? Okay. So let me know if you have any questions so far. Okay. So we have created these things now. We have not yet created any machines. Right? We will use this diagram itself from now. Okay.
I have one question, just a clarification.
Yeah.
So we cannot associate one subnet to multiple route table, correct?
Yes, you cannot.
Okay.
One subnet will always be associated to one route table. You cannot have a subnet
One route table.
without association.
Okay.
It should be. It will.
Okay.
If you don't associate it explicitly, it will automatically associate itself with the main route table. So simply you cannot
Main route
have
table.
you cannot have a subnet. It will either be private or public. So which is why I said don't modify the main route table, because the main route table's rule has only local rule. So that in future, if anybody creates a subnet anywhere in your VPC, it will be a private subnet by default, which is more secure
By
than
default access.
which is more secure than a public subnet. So don't. So just leave the main route table aside. Create other route tables and you assign all this. So far, what we have created, everything is free, right? Because we are just defining the logical parts, the VPC, the subnet, the route table, to what it is associated, all that stuff, right? We will come back to the NAT gateway and all that stuff, right?
And respect to this, association with internet gateway. I mean, we are mentioning like 00/0 form, right?
Yes.
For internet gateway to to access the outside. Internet. IP ranges. Can we mention like in specific range, like instead of putting 00, is that if you are mentioning like that, will it go?
No, you can do that, but the meaning of that is not a public subnet. Yeah, we will see the other rules, right? We will see the other
Okay.
rules we can specify. But a subnet becomes a public subnet only if this rule is there.
Okay.
Only if 00 and IGW is there. Because the work of the IGW is to access the outside world.
Okay.
So usually it is going to be 00 and IGW. If you see this rule in a route table and any subnet associated to this becomes a public subnet. So you will see other rules. Suppose you want to go to a different network. right? Suppose say
Okay.
you want to go to
Yeah.
some 172.16.0.0. For that you have other stuff. So if you look at the route table, when I go to that, right? If I go to the route table and say edit routes, there are different possibilities, right? Some of them like you asked, right? They come under advanced networking, but yeah, we will see some of those things. If I go to route and I say edit routes, right? I can add a route for something, and the target can be different things, right? If you're creating a VPN connection, then you can say all the traffic
Mhm.
going to my office network, it should go through the
Yeah.
VPN connection, or it should
Okay.
go through the peering connection, or it should go through the NAT gateway, or it should go through a
Okay.
transit gateway. So there are different, what you said, targets possible for the different, what you say,
Okay.
the destinations which you want to reach.
Okay.
So we will see a couple of those things, right? For now, the most basic is you want to reach the outside world. That is in general internet.
Okay.
Anywhere outside your VPC you want to go means you are saying the traffic has to go through the IGW. The internal traffic is local. That is traffic reaching your VPC is local. Everything else is through the IGW. So when I create an instance and I show you the traffic flow, probably it will be easier for you to understand. Now we have not seen the traffic flow, we have just created the layout, we have not yet put any infrastructure
Okay.
inside. So the next step will be, we will create two machines, we will put one machine over here, one machine over here, and we will see how the traffic is flowing. Whether I am able to connect to the machine,
Okay.
whether that machine is able to go outside, or from outside is the traffic able to come inside, all that stuff we will see.
Okay.
Okay, so don't worry about the NAT gateway now. Okay, so next we will be using the security groups and the access control list, the network access control lists. Okay, right. So we will take a small break, right? 15 minutes break, and then we will continue, right? Because I will create two machines and I'll show you how the traffic is flowing. It will be easier for you to understand what is happening in the VPC. Okay,
Okay.
okay. So we will catch up at 9:20. Okay, approximately.
Okay.
Okay.
Yeah. Let's continue. Right? So we have created a few of this stuff, right? We have created the VPC. We have made our subnets private and public, right? We have created an internet gateway, right? That is, we have a rule to the so the subnet which is associated to the route table, which has a rule to the internet gateway, is called a public subnet, right? The NAT gateway, don't worry, we will come back to that. Okay, so now we have created the what do you say, the core of the VPC, right? The core what do you say, local network or VPC. So we will launch two machines, right? I will launch one machine over here and another machine over here, so that you can see how the traffic flows in the VPC. Okay, so don't worry about how to create a machine. If you are able to do it yourself, well and good, or you just watch me do it, right? Because again, for this we should learn EC2, right? But main here, concentrate on how the traffic is flowing, because the VPC will be the next topic. Sorry, EC2 will be the next topic. For now, we just need to know how the traffic is flowing, not how we are creating the instance, right? Instance is just a virtual machine, right? So I'm going to create two virtual machines, one in each, what do you say, subnet, and see from this subnet how the traffic is flowing, right? From the subnets, how we can access the machines, or how the machines go to the outside world, all that stuff, right? So let me quickly launch two virtual machines, one in a public subnet, one in a private subnet, right? I will launch, so you can use Windows or Linux, it does not matter, right? It is just to see how the traffic is flowing. Okay. I will choose a Linux machine, right? So I'm going to create this machine in the dev VPC, the private subnet, let us say, right? And then all these settings are what I will explain, right? I'm creating a virtual machine in dev VPC in the private subnet first. Okay. So the next thing is next concept is going to be security groups. right? While creating the machine itself, I will explain, right? So I told you, you get one security group and one access control list. So what is this security group? What is this access control list? So this security group is used for the instances. Instances means your virtual machines, and it is used for others, certain other stuff also, like RDS, load balancers, all this, right? So the security group and access control list, they are like two layers of protection. They are like the firewall, a type of firewall provided by AWS, which works with your VPC, which is there. You cannot create a VPC without these two. These are the bare minimum, right? So the security group, it works with the instance. That is, it is like the firewall for the instance. So your instance, that is your virtual machine, can have its own firewall inside the OS, Windows firewall, Linux IP tables, all that is inside the OS, right? Whereas the security group is provided by AWS. So every virtual machine which you create will have a security group. Okay? Every virtual machine which you create will have a security group associated with it. You cannot create a virtual machine without a security group, right? The security group will have inbound and outbound rules. Okay? So which traffic to allow inbound, which traffic to allow outbound, you can control using the security groups. And then you have something called a network access control list, right? So this network access control list is associated to the subnet, right? It is associated to the subnet, whereas the security group is associated to the instance. So the simple way to understand this is like, I'm not sure if I explained it yesterday, right? So you're living in an apartment, right? Let us say we are living in an apartment. So you have your apartment building, right? And you are staying inside a particular flat inside that apartment building, right? So if you see, your apartment will have a gate and a watchman, right? It will have a gate and a watchman, right? And then here you have a door for your house. So think of your house as the virtual machine or the instance, your server, right? And this as your apartment building as the subnet, right? So if somebody has to come to your house from outside, right? From outside this subnet, some traffic is coming. That is, somebody is coming from outside. Then first the watchman has to allow, right? Then that person will reach your door. Then if you allow, then that person can come inside. Same thing for the traffic going outside. So from your house, if you have to go out, then you have to be allowed outside through the door. Then you will reach your main gate. Then if you are allowed outside through the main gate, then you can go outside, right? So say for example, you have a ticket to a movie, right? You have a ticket to a movie, okay? So if you want to go to the movie, first they have to allow you outside the house, right? Does not mean if you have ticket you can go watch the movie. First they should allow you outside the house. Then you should be allowed outside your apartment. Then only you can go and reach the movie. Same thing, if somebody comes into your apartment, say some marketing people are coming, then what happens? Your watchman will not allow them inside. He will block them here itself. But if some courier is coming from Amazon, then he will allow them inside. They will reach your door. Here you will collect the package. If the package is not for you, you will say, sorry, it's not my address. You go to the neighbor, right? So you have basically two layers of protection that is provided by AWS out of the box, and we use these to control the traffic to and from our instances. So the security group, it works at the instance level. This is your security group. This is your network access control list, right? In AWS, this is the virtual machine which is inside the subnet. So the security group is attached to the machine, whereas the access control list is attached to the subnet, right? Both have inbound and outbound rules, but at which level you want to, block or allow traffic, you can do. For most of them, right, they manage everything with the security group. That is by default, right? So when you create a VPC, you get an ACL, right? The network access control list. Default ACL, default security. The network access control list is automatically associated to all the subnets. So whenever you create a subnet, the default ACL is attached to it. That is, the rules in the default ACL apply to this subnet, any subnet which you create. If you want, you can create different ACLs, right? Okay. So the default ACL, the rules in the default ACL apply to all subnets that you create normally. If you want, each subnet can have its own ACL. So remember, the ACL, the network ACL, the network access control list, it works at the subnet level. And the security group works at the instance level. So security group, whenever you are creating a machine, you attach a security. You don't attach a ACL to the security. Sorry, you don't attach a ACL to the machine. The machine is in the subnet, so everybody in this subnet have to follow the rules of the ACL. So other apartment people also, they have the same ACL, right? Whoever is living in your subnet, right, in your apartment building, they have only one ACL. They can't have two ACLs. The neighboring apartment, he might have his own watchman, right? Or your watchman is doing the duty for both apartments, something like that, right? So each subnet can have only one ACL, but there can be multiple ACLs, right? So you can have another ACL for another subnet, but each subnet will have only one ACL. Okay, so the ACL is working at the subnet level. So everything inside that subnet, the has the same watchman. That is the ACL. But the machines can have their own security groups. You do this. You associate. So I'm creating a, say, a DB server. So it will have one security. Say DB security. You are creating a app server. So app server maybe will have the app security because the rules may be different, right? Because for app server maybe you want to open port 80 and port 443. For DB server you want to open port 143. 1431 or 1432, whatever DB it is, right? So which is why we said, right, put the similar stuff in the similar subnets. Don't mix and match, right? Because similar machines will have similar, inbound and outbound rules. Okay. So the security group you associate while launching a machine. You say for this machine use this security. The ACL is inherited from the subnet in which the VPC is, the ACL is inherited based on the subnet in which the machine is located. So in our case, we have only one subnet, one ACL, that is the default ACL, right? We have only one ACL. If you look at our VPC, we have only one ACL, and it is associated with both our subnets because we have not explicitly created any new ACLs. So if you see, it is associated with both my subnets. So both my subnets have the same default ACL. If you want, you can create another ACL, have a separate ACL for each subnet. So we will see how they work. But first, like I said, for most people, they manage the traffic using security groups. The ACL by default allows all traffic. The default ACL which is provided, it allows all outbound and all inbound traffic, right? So both the security group and the ACL, they have inbound and outbound rules, right? The ACL by default allows all in and out. It is like your apartment watchman. He allows everybody in and everybody to go out. We control the traffic over here. So if somebody is coming, you can allow him or you can block him. If somebody wants to go out of your house, you can either allow them or not allow them. So for many people, controlling the security here might be sufficient. They don't need to mess with the ACL. In some cases, you need to modify the ACL. Okay, where we need to modify the ACL or for what reason we modify the ACL, we will see, right? But security group is, for a lot of people, just controlling it at one place is enough. They don't need to change both. So by default, the ACL, it allows all inbound and all outbound traffic. So the traffic is not blocked at the ACL by default. It is only blocked or allowed by the security. Okay. So now I'm creating a virtual machine, right? And so the step is going to be, one of the step is going to be to configure the security group, right? So I will say create a new security group. So you can use the default security group also, like I said, right? There will be a default security group, but again, mostly nobody uses the default security group. It is just there, right? We can create our own security. So I'm creating our own security group, right? And where am I creating this machine? One second. We are so we are creating this in the private subnet. Okay. We'll say I will simply call it private security. Okay. And I am opening port SSH. Right. So the security group has inbound outbound rules. So here you configure the inbound rules. So I'm saying add rule. Right. So because it's a Linux machine, I need to log into it. Right. So here you have to explicitly allow the inbound traffic or outbound traffic. So if you want to connect to the machine over SSH, you should open the SSH port. If you want to connect to the machine over the RTP, you have to open the RTP port. If you want the machine to access the outside internet, you have to open the HTTPS port. If you want to connect to this machine, it has a DB running, you should open the DB port. If this machine it needs to send email out, you should open the SMTPS port. So you should know what service is running on the machine, what ports need to be open. Right? So I told you you have a number called, so suppose now let us just start off with SSH. So this is a Linux machine, I need to log into it. Right? So I'm saying SSH. Some well-known, what you say, services are listed over here. If you want to open any other port, you can just specify the protocol and the port number. These are some common, well-known, commonly used services and their port numbers: HTTP, HTTPS, IMAP, POP, HTTP, HTTPS, right? The database related ports. These are all the default ports, like Microsoft SQL Server is 1433. Suppose on this server I have a Microsoft SQL Server and people need to connect to it. I need to open this port. Inside the OS, you might have Windows Firewall, Linux Firewall. That is, you are inside the OS heading. That AWS, that is not managed at the AWS, right? But at the AWS side, every virtual machine will have a security group. You cannot create a virtual machine without a security group. That is your EC2 instance in Linux. Sorry, in AWS. Okay, so the traffic will either come into your machine or go out of your machine based on the inbound and outbound rules. So here what we are configuring is the inbound. So first I want to log into the machine. So I am opening SSH port. What is SSH? The default port is 22 TCP port. If you are putting SSH on a different port, then you need to open that particular port. The default SSH port is 22. If you are putting SSH on 26 port, then you simply say TCP, because SSH is a TCP protocol. Instead of 22, you put 26. If you are if you are running the SSH service on a different port, or you can simply say custom TCP 22. It is the same as saying SSH. These are simply the well-known traffic names. The actual thing is what protocol and what port, right? So SSH is TCP 22. You can either choose SSH or you can say custom TCP and put 22 or whatever the port you are running on. Okay. And next is the source, that is from where do you want to allow this traffic. So if I say anywhere, that is 0000/0, and what is this :/0? It is the IPv6 equivalent of 0000, right? 0000 means what? To anywhere or from anywhere. If it is inbound rule, it is from anywhere. If it is outbound rule, it is to anywhere. That is, you are saying allow people to connect to this machine from anywhere. Okay, so you will see a warning whenever you put 0000/0, because it is not a good practice. Okay, so you don't want to open your ports to the entire world. So if people need to log into this machine, if you see in real time, maybe they will be allowed to log into this machine only if they are in the office network. They go home, they cannot connect to the machine. So to connect to a machine, normally what information you need? You need the username and password. Right? That is the first thing. right? You need the credentials, and then the port has to be open, right? So if I say anywhere, if I say source anywhere, and you have the username and password, you can connect to this machine. Whether you go home and connect, or from office, or anywhere, from anywhere, you will be able to connect. And other people also will be able to try to connect to this. They may not have the credentials, but why are you unnecessarily exposing it outside? Why are you exposing this port to the outside? It is not required, right? If you expose, it will work. You can connect, anybody can connect. Anybody who has the credentials from anywhere, they will be able to connect, right? So what we will do real time is, right, the best practice AWS itself says, don't open the ports to the entire world. 00 is, we call entire world, right? So whether it is incoming traffic or outgoing traffic, try to avoid using 00. In some cases you have to use, we will see what are those cases, but for these ports like SSH, right, RTP, database ports, these you should not open to the entire world, right? So you can put it to custom. That is, you can put your office's CIDR. So your organization company, they will have a public IP range usually, not like our home. At home you don't have a static public IP, right? It will change. If I reboot the router, right, and tomorrow I try to connect, it will not work because my IP would have changed. But in your company, they will have a static IP, right? So they can put that IP range over here, right? Say your company uses something like this, right? They might have a single public IP, or they might have multiple public IPs. They will give you the range. What is the range? What is their public network CIDR? They will give you, right? Maybe it is something like /25. So maybe your company has some 7 IPs or something like that, right? Or 16, 17. So from all the IPs, you should be able to connect, right? So when you go home, even with the server's ID and password, you cannot connect because that server is allowing traffic only if it comes from this source network. Okay, so you can say custom, or you can say anywhere, which is not good, or you can say my IP. My IP means it will pick up my current public IP. That is my network's current public IP. So, like I said, if you are accessing the internet, you have a public IP. You might not have a static public IP, but you have a public IP, which is provided by your ISP. It will change. It might change every day, or if you reboot the router, it might change. Right? So my current IP is this 49.204.178.27, which is what is showing over here. Okay. Tomorrow that IP will change, so the security group will not update itself. Now if I reboot my router, my IP will change, but here in the security group, this IP will remain. So if I try to connect to the machine again, it will not connect because my IP has changed, because the source IP has changed, but it will not. You have to go and modify the security group, right? But in your organization, they will have a static IP, so that IP will not change. So only when you come to office, you are connected to that particular network, either over VPN or physically in office. Then only you can connect to this machine, something like that, right? So I will say my IP, right? I don't want to put anywhere, right? So I will be able to connect to this machine from my IP, that is currently my network, right? So we will see how all this works, right? And I'm going to say launch. So don't worry about these credentials and all these things, right? So this we will see in EC2, right? Have a keypad. Okay. So I'm creating this machine. Okay. So this machine is being created. So this machine is in the which subnet? It is in the private subnet, right? So I will just call this the private machine, just for our identification, right? So think of this maybe like the DB server or something. So let me launch another machine. I will launch it in the public subnet, right? We will launch it in the public subnet. Here also security group. So let me create a new security group for this. This is the public security group in Canada. Right. So here also I'm opening the SSH port from my IP and I'm going to launch it. Okay. So here remember, two machines can share the same security group. Right. Two machines can also share the same security. They don't have to have different security. Like I said, if you have app servers, if you have 15 app servers, the rules will probably be the same. So you are not going to have 15 different security groups. So every machine needs a security group. So similar machines will have the same security group usually in real time, right? So for high availability architecture, so we need to use multiple subnets, right? We saw yesterday, right? We need to use multiple subnets to achieve high availability. So when you put the different, what do you say? When you use different subnets in different availability zones, say you have a subnet in availability zone A and B for the app server, right? All of them are app servers. For high availability, you're splitting up into two availability zones. You have two app servers. One you're putting in A, one you're putting in B. But they both have the same content. They are the same app servers. So you can have a single security group. You can have something called the app security group. Maybe in this you're opening the port 80 HTTP for Tomcat. Right? So this app security group can be attached to both the instances. You don't need to have two separate security groups because these machines will always have the same rules. You can have for this separate, but unnecessarily you are creating too many security groups, which is another reason why you want to club your similar stuff. Right? If you have Oracle database, two Oracle database, okay, they will probably have the same rules. Same rules. That is, people in your office need to connect to it. Nobody else should be able to connect to it. It is a Tomcat server for some project X. So probably it will have the same rule. You're opening port 80 so that everybody can access it. So you don't need to create two separate security groups. If you want, you can. Right? So security groups can be, every instance will have a security group, but the same security group can be there for multiple machines. Okay? Even though I told you it's a door, like you might have your own house door, but like I said, the exception is you can have a security group, one security group attached to multiple machines, especially if they have similar rules. If they have the same rules, then you don't have to create two security groups. Okay? So the security groups are also free. What you pay for is the virtual machine. Okay? So I've just created the machine. So let us just wait for a couple of minutes while the machines are being created. Then we will see how the traffic is flowing, whether I'm able to connect to the machines also. Okay. So give me a minute. Just I'm getting the credentials ready. Just I'm getting the credentials ready. So our machines have been created. Okay. So now we will see how the traffic is flowing. We have our VPC, right? So now let us see how this traffic is going to flow. Okay. So the first thing that I'm going to show you is, okay, so where am I located? I am currently outside AWS. I am on the internet, right? I am here. Okay. So now first what I'll do is I will try to connect to the machine in the public subnet, right? We have created a machine in the public subnet. So I will try to connect to this machine. Okay. So don't worry about how to connect and all that. I'm connecting using SSH. If you know how to use PuTTY, you understand, right? So if you know how to use PuTTY, have you used it to connect to some server or something, Linux servers or Windows RTP? That's what I'm doing. Okay. So how do I connect to this machine? I use a SSH client. So what information is required to connect to that machine? I need its credentials. Okay, I have its credentials. Then I need its IP address. Okay. So I'm connecting to the machine in the public subnet. The public machine is in the public subnet. Okay. So to connect to this machine, I need this machine's IP. So do I need its private IP or public IP? Right? So your machines in the private network will have a private IP. You will not have a public IP. But in AWS, you can directly assign a public IP to your machine. Right? You can directly assign a public IP to your machine. Your machines will have a private IP compulsory. Right? It is just like any machine in a network. It will have a private IP. So this private IP will be what? It will be the CIDR that you specified. What is the CIDR for this subnet? 10.0.0/24. So the IP will be between 10.0.0.1 to 255. First 4 and the last one will not be there. So if you see this machine, it got a private IP of 10.0.0.118. But I cannot connect using the private IP because I am coming from the outside world. Right? Because I am coming from the outside world, the private IP will not work. It needs the public IP. Okay. So I have assigned a public IP for this machine also. It has a private IP, and additionally I have given it a public IP also, so that I can access this machine from the outside world. Right? So I need to use the public IP because I am coming from the outside world. Okay. So let me try to connect to this machine. Okay. So you see I am able to connect to this machine. Don't worry about the credentials, but you see I am able to log into this machine, that is 0.118 from the outside. So why I am able to log into it? Because I have opened that port. Right? If I go to the security groups, right, we created the public security group over here, right? So let me just put the name over here, public security. And this is the private security. Right? Default we are not using. It is just there. Okay. So the public security group is attached to the machine in the public subnet. Right? So this machine, public machine, has the public security group. And in the public security group, what is the inbound rule? I am allowing SSH from this source. And what is the outbound rule? So whenever you create a security group, usually all outbound traffic is allowed. Again, it is not a good practice to allow all outbound traffic. You need to edit and remove this. By default, all outbound traffic will be allowed. So I am allowing inbound SSH from this IP, which is why I am able to SSH. If I remove this rule, so let me go ahead and remove the inbound rules. Okay, there is no inbound rule now. There is no outbound rule. Okay, there is no inbound, there is no outbound rule. So now will I be able to SSH? So let me close this. Now again let me try to connect to this machine. Right? So now you see I will not be able to connect. Why I am not able to connect to the machine? Because the security group associated to this machine is not allowing any inbound traffic. Inbound, no traffic is allowed. Outbound also, no traffic is allowed. So I'm not able to connect to it. Okay. So if you want to allow SSH inbound, then you need to open the SSH port. For any port, it is the same, right? So SSH port I'm open. From where I want to allow SSH? Is it from anywhere or from a particular IP range or from my IP? Because I don't know what is my IP, because my IP can change. So they have added an option called my IP so that it picks up your current IP. This will not update itself automatically. If your IP changes, you have to update this rule. Okay. So I'm saying my IP because I don't want anybody else even trying to connect to the SSH, even though they might not have the credentials, right? You don't want to open it. Necessary, you should not open the ports. So even if I say anywhere, it will work. If I say anywhere, SSH will work, right? I can say save rule, right? So these rules take effect immediately. You don't need to reboot your machine or anything. Right now, if you see, if I say restart, you see again it is working. Right? You don't need to restart your machine or anything. Okay? So the first thing is don't open ports like this. Even though it will work, some people do that to make their work easier. You should not do that in real time. If you see anything, any rule with 000, you should go and investigate why 00 is open. Is it really required? Right? So SSH you should not open 00. So usually you open it to a specific IP or a group of IPs, depending upon how many you have. Right? So if you want to open it for another IP, you can do it. You can say open SSH for that IP and also for another IP. You can add like this also. Sorry, something like this. Say your office has 2 locations or something, right? The IP of one location is this, the IP of one location is this. Maybe they are not in the continuous range, right? So maybe they have 2 different IPs, they can add it like this also. So SSH will be allowed only from this IP and this IP, that is from these 2 networks, right? So you can add like that as many rules as you want for whatever type of traffic you want to allow inbound. Okay, so now I am saying save. So now will I be able to SSH? Yes, I will be able to SSH. But if you look outbound, there is no traffic allowed. Okay, inbound I'm allowing SSH, outbound I'm not allowing any traffic. But if you see technically, right? So let me open, right? So we have a EC2 instance. So now I will remove all that that VPC and all that stuff. Let us just look at the instance which is in the public subnet. Okay, so I am able to connect to that machine from outside. Why? Because this machine has a public IP. If it does not have a public IP, I will not be able to connect it from outside. And why I am able to connect? Because the security group, right? Because the security group inbound is allowing the traffic. It is allowing SSH from my IP. I am able to connect to the machine. But for this machine, it has a security group with the outbound group also. Outbound, I am not allowing any traffic. So technically, when you are making a connection to this instance, the instance is giving back a reply. Right? Instance is sending outbound traffic. What is that outbound traffic? This is what is the outbound traffic. Right? I'm connecting to the machine. The machine is replying. So you don't need to open the outbound traffic. To connect to the machine, you don't have to open outbound port 22 or something. The return traffic is automatically allowed. Right? The return traffic is automatically allowed. So if I establish a SSH connection, the reply from the machine that I get, that is the outbound traffic. Right? That outbound traffic is automatically allowed. You don't have to explicitly allow it. So if somebody comes to your house to deliver a courier, he can go back out, right? You don't have to give him permission to go. So same thing here. You just have to allow it inside. The return traffic is allowed automatically in the security. You don't have to explicitly specify that. Okay. So for any traffic, if you open inbound, there is going to be an outbound reply, right? So in a security group, you explicitly don't have to specify the outbound. Okay. For these type of things, where you will specify outbound. Okay. So outbound means you are saying from this machine something wants to go out. So from your house, if your kid wants to go out and play, you have to give permission, right? But if the neighbor's kid comes inside to play, you have to allow him inside. He can go back to his house. You don't have to give him permission for that. You have to give him permission to come in. So same thing here, right? The return traffic for any incoming is allowed automatically. But if your machine, from your machine, some traffic needs to go out, then you have to allow that. From your machine, if some traffic has to explicitly go to the outside world, then you have to allow it. Now say for example, I am logged into this machine. Say from this machine, I want to go to Google. Right, so now if I try to ping Google, will it work or not work? Right, I want you to just be a little interactive so that it will be easier for you to understand the traffic flow. Because we might have some assumptions that it will work, it will not work, right? So now if I try to ping Google, will it work or not work?
No, it won't.
Okay, let us see. Okay, so you see it is not working. It is not able to reach Google. Okay, so now how do I allow it to reach Google? Now I will say security group. To make my work easier, I will go to outbound and I will say add rule. I will say all traffic. I will say allow all traffic to anywhere outbound. So now if I try to ping, will it work? Now you see ping is working because I am allowing all outbound traffic. Okay, but again you should not allow all outbound traffic unless it is required. Now let us say I am not allowing all outbound traffic. Okay, I am let us remove this. Now I am going to give only internet access. So how do you generally give internet access is you open port HTTP and HTTPS. That is the default port 80 and 443. If you want to give internet access for some machine, you open HTTP and HTTPS to where? To anywhere. Because you don't know where which website is located, right? If you want people to access the entire internet, you say you can access traffic on port 80 and 443 located anywhere. So these type of things maybe you need to open to 00 because we don't know where Google is, where Yahoo is. We don't know their IPs, they may change. So if you want somebody to be able to access the internet from that machine, then you can say open port 80 and 443 to what is the destination to anywhere. And now save. So now will I be able to reach Google? Right? Now if I say ping google.com, will it work or not work?
This will work.
Okay.
Sure.
You see it is not working. Why is it not working? Because ping is not what do you say? It is not HTTP. What is ping? It is ICMP. Ping is ICMP. Okay. So only HTTP traffic will work. No other traffic will work. Ping will not work. Your email will not work. What is email? SMTP. Suppose your machine needs to send an email out. You need to open the SMTP. HTTP port works only for the web traffic, right? So what is ping? It is ICMP. So you need to open ICMP, say to anywhere, then ping will work. Now if you see ping will start working, you don't need to reboot the machine or anything. Security group rules take effect immediately. Okay, so simply because you have internet access, it does not mean ping will work. Ping is a different port. What do you say? A different port and a different protocol. It goes on a different port and different protocol. Okay, so now say I remove this rule. I remove this ICMP rule. I have established a ping. A ping is going on continuously, right? So let me again stop it and again show it. Okay, so let me clear the screen. Right now you see the ping is going. Now what will happen if I remove this rule? While the ping is going on, I'm removing the rule. You see still the ping is continuing. Okay, so here what you have to remember is, so if a connection is open, so here a connection is open. When the rule was allowed, the connection was open. So when you remove the rule, until this connection closes, that process or that traffic will continue. So now ICMP is not allowed, but still ping is working because I had already established that connection prior to removing the connection. Now if I break this connection and I try ping again, it will not work. If a connection has established and you modify the rule, it will wait for that connection to finish. Right? Future connections will not be allowed. Okay, so sometimes, like I said, now I put ping and you remove the rule, still it is pinging, means you started that ping even before removing the rule. So that will continue until you break or that connection ends. Okay, so now from this machine, if I try to access the internet, right? Internet means say I'm trying to go get some updates, right? So in Linux we say sudo yum update. So in Windows you can just open the browser and see if you're able to access the internet, right? So now I'm trying to do some updates for the OS. So it goes to the internet and tries to get it. So it says there are no packages for update because this is properly up to date. So let me try to install something. So I'm installing Tomcat, sorry, Apache. Okay, so it needs to download the Apache package and install. So it will go to the internet and get the package. So because I have allowed internet access, it is able to go to the outside world, right? And it is able to install Apache. Okay, so now internet access is working. So it depends upon what port, what protocol you're opening. This combination. So internet access, it does not mean everything will work. So from this machine, if I try to now, what do you say, to SMTP emailing, if I do, it will not work outbound. So you can control each and everything, right? So what you want to allow inbound, what you want to allow outbound. If you want only people to connect to this machine and use the internal, what do you say, services, right, within the LAN, within your office network you have. So suppose think of this as the machine into which you log in, and from here you connect to the DB server. So the DB server is in the private network, so you can connect to the DB server and work. You don't have to go to the internet, right? Internet access is not required. You just need to log into this machine from the outside world. For that you need to open inbound rule. Outbound rule is not required. So from this machine, if some traffic needs to go out, or from this machine you want to connect to another machine, right? Now from this 118 machine you need to connect to another machine, then outbound is required. Okay, so that is how the basic security groups work. So any traffic that you open inbound, right? If you allow inbound traffic, its return traffic is allowed automatically. You don't have to open any output. But explicitly, if you need to send traffic from a machine to the outside world or to anywhere, not only to the outside world, right? If you need to send explicitly traffic out, then you need to open the appropriate outbound route. So everything has its own route. So this is not only AWS, anywhere in networking. So internet access means a certain group of ports. What do you say? Ping means ICMP related you have to allow. If you are using Oracle or a SQL Server or whatever, it will have its own port, right? 1433 or something like that, right? If you want to allow the remote desktop, it is 3389, SSH is 22, right? Suppose from this machine, right, I want to connect to another machine. It may be in AWS, it may be outside AWS, it can be anywhere. Then you have to open outbound SSH, because from this machine you are connecting to another machine. So you have to open outbound SSH. Inbound SSH is only for incoming connections. So from this machine, if you are opening, if you want to connect to other Linux machine, then for this machine you have to open outbound SSH. For this machine you have to open inbound SSH. Otherwise you will not be able to connect from this machine to another machine. Okay. So I will show you that also. Okay. So now what do we have? Okay. So now I am able to connect from the outside world into the machine in the private, to the machine in the public subnet, right? So from the outside world, I'm able to connect to the machine in the public subnet. Now let us say I want to connect to the machine in the private subnet. That is, I want to connect to the machine over here. So how do I connect to that? Same thing. It is a Linux machine, so I'm going to use SSH. Okay. So let me open another connection, right? And I need the machine's IP. Okay. I need the machine's IP, the private machine's IP. So the private machine also has a private IP in its range, in its subnet range, and it also has a public IP. I have given it a public IP. Okay. So now because I am coming from the outside world, I need to use the public IP. So now I am connecting to the machine in the private subnet. Now will I be able to connect?
Yes.
Okay. You see, I am not able to connect. So if I am not able to connect, then the first thing that you need to check is the security. If somebody says, this is from troubleshooting point of view, somebody says I'm not able to connect to the server. He has the credentials, but he is not able to connect. Then you need to go and check, okay, for the private machine, it has a different security group. Okay, I'm going to go and check inbound. Somebody is connecting into that machine. So is SSH open? Okay, SSH is open. Is it the correct IP? Is he coming from home or is he coming from office? Okay, he is coming from home. His home IP is here, but he is not able to connect. Why he is not able to connect?
Because the routing
Maybe.
table
Yes, because the
mentioned the
machine
private.
is in what we call the private subnet. So if the machine is in the private subnet and you give it a public IP and you open all the ports also, traffic from outside will not come inside directly because it does not have a path to come in. It does not have a path to come in. So even if you give your machine public IP, you open all the ports, traffic from outside will never come into the private subnet. So it is like what you say, like your machines in your home, right? In your home you have a Wi-Fi router and you have all the machines sitting behind it, right? So the private subnet, I told you, it is somewhat like your LAN at home, right? You have a Wi-Fi router, right? That is basically you have a LAN, right? You may be able to access the internet. You may be able to access the internet if you have an ISP, but nobody from outside can straight away come to your machine unless you, what do you say, you open a path and keep. Unless you open TeamViewer and give me access, I cannot come in. That is, I cannot straight away put your machine's IP and come inside because you are not exposed to the outside world. You are protected by this device, right? Your internet connection is handled by the router. Your devices are in the private network, right? People from outside, they cannot come directly into your machine, right? They cannot directly SSH or RTP or something. If you open a path or something like TeamViewer or something, then they can come in. That means you are only opening, they are not opening, right? So the machines in the private subnet, it does not matter even if you open all the security group ports, right? Traffic from outside will not reach them. Traffic originating from outside will not reach them. So it does not mean that you open all the ports. You should not open all the ports even if they are in the private subnet. I'm just showing this as an example. So even by mistake, like I said, so critical machines like DB servers which don't need to be exposed to the outside world, it is a good practice to keep them in a private subnet. So that even by mistake, if somebody opens the DB port to the entire world, the connection will not come in, right? So even if you give the machine a public IP, there is no use because it does not have a path to come in. There is no internet gateway. So for the traffic from the outside world to come in, or right, you need a internet gateway. We don't have that for the private, which is the reason why we call it a private route table. Sorry, we call it a private subnet. There is no such thing called a private route table. We have just named it as a private route table. Right? A subnet is considered a private subnet if it does not have a route to the internet gateway. If it does not have a route to the internet gateway, then traffic from outside will not reach this machine. So how do I log into this machine? I want to log into the DB server. So I am outside. So how can I log into this machine?
You can edit the route table.
No, if you edit the route table, it will become a public subnet, right? We don't want it to become public. Yeah. I want to keep it private, but I still want to log into that machine.
You can give
that VPN we need to use.
Okay.
We can use VPN.
Yeah.
Through VPN we can access into this.
Yeah. VPN is also one of the possibilities. So we are not going to VPN now. We are not going to advanced networking. Without VPN, I want to. So the option is simple. You go into the public subnet. From here, you come here. So how do you connect to the machines in your office? First, you connect to some machine. You connect to some VPN or some machine. From there, you connect to the other machines in the LAN because they are in the same LAN. If I connect to any one machine in the network, from there I can connect to the other machines because they are in the private network. They will be able to talk to each other because both have the local route. Both are the same VPC. Right? So what we need to do is we need to go to some machine in the public subnet first. From there we can come to the machine in the private subnet. So now here I have already logged into the machine in the public subnet. Right? 118 is the public subnet. So I can log into 118 machine, and from here I can log into the machine over here. So what is that machine's IP? So there I don't need to use the public IP. Public IP is not required for machines in the private subnet. If you want, you can give. There is no point of that. Right? I have simply given to show you. So I can use its private IP. Private IP will work only if it is traffic within the VPC. So now I can connect to 10.0.186, which is the second machine. Right? 10.0.186 is the second machine. So I can connect to this thing from 118. right? So let me see if I'm able to connect to 10.01.86 from 10.00.118, because 1.86 I cannot connect from outside, even if I open all the ports, right? Right? I open port SSH. I'm not able to connect from outside. Now let me try to connect from the machine in the public subnet. At 10.01.86. So now will I be able to connect or not connect? I'm connecting from the machine in the public subnet to the machine in the private subnet using its private IP, because they are in the same network. They are in the same VPC. So will this work or not work?
It should work. Probably we are not offering the 22 port for
Yes,
exactly. This IP probably we not able to.
So if you try to SSH, it will not work. Why it is not working is because SSH is allowed only from this source. So you should not assume that just because two machines are in the same VPC or in the same subnet, they will not be able to communicate with each other, because they have their own security groups. Even if both the machines are in the same VPC, even in the same subnet, they will not be able to communicate to each other, because each have a security group. Right? Only if the security group allows the traffic, it will come. Whether it is coming from outside world or from within the same VPC, the security group has to allow. Here, what the security group is allowing, it is allowing SSH only from this source. But now, what is the source? Now the source is 0.118. Right? The source is 0.118. So SSH is coming from this source to this machine. So it will not allow. You should not assume that both the machines are in the same VPC or same subnet. I'm not able to connect. It will not connect. The security group, all the traffic has to pass through the security, right? So you need to update the rules. Now I can say allow SSH. I can put custom. I can put this machine's IP. I can say 10.0.0.118. How can I say that? I can say 10.0.0.118 slash. Don't, you should not say just 118. You should say slash 32 if it is a specific IP. Okay. So now SSH will be allowed only from 10.0.0.118. Sorry, I forgot to put a dot over here. Okay. Now if I try to SSH, I hope I edited the correct security. Okay. Private security group. Inbound 10.0.118 is the IP, right? Okay. So now why I am not able to SSH? SSH is not working. I know why it is not working, but why is it not working? Any idea?
Probably that SSH. I mean 118. Rules we need to modify.
Yes.
Like here also we are allowing.
Yeah. So from 118, which is the public machine, right? Outbound, I am not allowing anything.
Yes.
So what is happening from 118? Outbound is going SSH to this. So here you have allowed inbound, but from 118 outbound SSH you didn't allow.
Yes.
So you need to allow that also. So if SSH is not working, either the inbound rule for the destination is not there, or for the outbound rule for the source is not there. So only if it goes out from this machine, it can reach the other machine. So here you need to open outbound SSH. It is not enough if you have inbound SSH for the private machine. Inbound means it will allow inbound connection. Now from this machine, I am trying to access another machine. So in the other machine, I have allowed inbound, but from this machine, there is no outbound traffic allowed. So I am going to allow outbound. Outbound what? I want to allow SSH. To which location? Again, don't put 00. You can put that other machine side. 10.0.1.186. I can say custom, and I can say allow outbound to 10.0.186/32. So now if I try to SSH, maybe it should work. Now you see it is working. Okay, now you see I'm logged into 10.0.186. Okay, so real time how people might do, right? So now here we have added that specific machine's IP. So I'm saying we have only two machines. So I'm saying from this machine you can access the other machine. I'm putting that machine's individual IPs, right? I'm saying from this machine you can go to 1.86, right? Or from here I'm allowing inbound from 0.118. But say in real time how it will work, right? Practically speaking, right? All this applies real time, but so in real time you might have 100 machines, right? In your infrastructure, they are spread across different subnets. Let us say, right? Let us say you have so many machines. Some are in the private subnet, some are in the public subnet, right? So and you have many employees, right? You have many employees. Let us say some people access this particular machine, this particular guy accesses this machine, this guy accesses this machine, these three guys need to access this machine and also this machine, right? So there will be overlap, there will be people who are accessing, who need to access different machines, right? So how do you, what do you say, configure that? Okay, some machines are in the public subnet, some machines are in the private subnet. There are many people, they need to access different machines, they have their own credentials, everybody has their own ID and password, right? So how do you manage something like this? With two machines, fine, I'm able to add that particular machine's IP or something. So here what you can do is, right? So we know you cannot, nobody can reach the private subnet. If somebody has to reach, if these two guys have to reach the private subnet, they need to go through the public subnet. So they cannot straight away come here. Even though I said they need to access this machine, how can they access? These two guys have to come like this and go like this, right? So what we generally do is, right? So we create a machine in the public subnet. We create one machine in the public subnet, and we ask everybody to connect to that first. Everybody, you connect to this first. So for this machine, I will open inbound SSH from the office IP, so that whenever they are in office or over the VPN IP, right, I will open the inbound SSH. So all these 6 people, they can connect to this machine. So they will come here. So from here, they can connect to all the machines, whether it is in the private or public, right? From here, they can connect to this. From here, they can connect to this. They don't have to connect to the public machine directly from outside, right? Your machines may be in the public subnet, but you don't want to open all the machines ports SSH to the outside world, right? Some in many cases, people don't use a public subnet at all. They put everything in the private subnet, right? So everything is in the same network. The private and public is just a segregation within your VPC. So what all the 6 people will be required to do is they will log into one common machine. From there, they will, like how I did, right? From 0.118, I connected to 1.86. So from 0.118, I will connect to 1.87, 1.88, or whatever. Even if it is in the public subnet, I will connect using their private IPs. So what I can do is, instead of adding each machine's rules, right, I can add the entire CIDR. In the security group, I can say, right, here I'm saying allow, in the private machine, I'm saying allow SSH only from this IP, right, only from this machine I'm allowing SSH. Or what I can say, suppose 86 needs to be connected, right, across. So here you can specify the VPC, sorry, that subnet CIDR also. If you want to allow connection between all machines, instead of specifying each machine's IP one by one, you can specify the entire CIDR. What is our CIDR? 10.0.24, right? So what is the meaning of this 10.0./24 means? That means I am allowing inbound SSH from this entire network, not a single IP, all IPs in this network. So let me close this connection, right? Now I'm connecting from 118 to 86. But how am I doing it? So inbound on the 86 machine, on the private subnet machine, I am saying allow SSH from anything in this subnet. What is 10.0.0./24? I hope that number is correct. According to our diagram, 10.0.0.0/24 is the public subnet, right? So now I am saying allow SSH from anything in the public subnet, not just a particular machine, from any machine in the public subnet. Because like I said, there will be people who are accessing multiple machines, right? From one machine to another machine within the network you are allowing, not from outside. Okay, so you can open a specific machine's IP or you can open a range of IPs. That's why I said if your office has multiple public IPs, they will give you a range. If it is a single IP, it will be /32. So here 10.0.0/24 what is my entire public subnet. So now if I try to SSH, will it work? If I try to SSH to 1.86, will it work? It will work, because SSH is coming from where? From 0.118. What is 0.118? It is a part of this 0.0/24. You understand this part, right? So you can specify the source as a single IP or a range of IPs or the entire subnet itself, or maybe the entire VPC also you can say. If you want anybody in the VPC, right, in any subnet, tomorrow you create another subnet, whatever, you can put the entire VPC CIDR instead of what is /24, it is my public subnet CIDR. Now I want to allow anybody in the VPC to SSH to this. I will say /16. What is /16? It is the entire VPC. Now if I close the connection and again come, right, from 0.118 to 1.86. So it will work because it matches this, right? So you can, what do you say, the source can be a single IP or a group of IPs. That group of IPs can be your public IP, it can be your VPC's entire CIDR or a particular subnet's CIDR, right? So depending upon how you have organized the network in your architecture, right? So if you want everybody in the private subnet to be able to access all the machines in the public subnet SSH, then maybe you can open. So you can lock it down as much as you want or open it up as much as you want. So in real time, we are not going to open SSH for multiple machines to the outside world. We expose one machine from the office IP or VPN IP. People connect to that machine. From that machine, outbound will be allowed. So from this machine, what will happen? Inbound SSH will be from the office IP or VPN IP. The outbound rule will be SSH to maybe the entire VPC, or maybe SSH to the public, CIDR and the private CIDR. So from this machine, people will be able to SSH to any machine over here and here, but they will not be able to connect to any machine in another subnet. You may have another public subnet also. In our example, we just have 2. In real time, there might be 6, 7, 8 subnets also. So maybe the people in this subnet, they need to access only these 2 subnets. So accordingly, you can open, right? So you can say SSH, outbound SSH from this machine will be allowed only to this public subnet 1 and private subnet 1. So whoever has whatever credentials, they will be able to access their respective machines. You don't have to add individual rules, multiple rules.
Is this approach called jump server?
Yes.
Sometimes.
Yeah, so that's what I'm coming to. So this machine, we call it in AWS, it is called a bastion host. Or like you said in the outside world, it is called a jump server or ITPC or whatever. In AWS, the term used is a bastion host. It can be any Windows or Linux machine. Its only work is its main work is to accept connections from outside, and then from there, people connect to the other machines. They jump to the other machines. Right, in the outside world, we call it jump server. In AWS, we call it a bastion host. It is not any special machine. It can be any Linux or Windows machine. If you want, you can use it. It is not compulsory, but it is recommended. right? Like I said, you can open the IPs for everything, but it is not a security good practice. So it is better you keep one machine, and for this don't open SSH from everywhere again. So if you see 000, it is dangerous. Why they have opened 000? You have to ask. If you put 00, it will work, but it is not a good practice. Okay. So even for the jump box, we should open SSH inbound only from the required IPs. If you are allowed to connect from home, then maybe you can open 000 because probably nobody at home has a static IP. Mostly what people will do, they will ask you to connect to the VPN. When you connect to the VPN, your office will assign a public IP to you, the VPN's IP. So usually they open SSH from the office IP and the whatever is assigned to the VPN, so that people can connect to this machine either when they are physically present in the office or when they are connected to the VPN. Otherwise, they cannot connect to the servers. Right? Anywhere, whether it's AWS or even in your your on-premises network, this is what happens. So what you are doing in on-premises, you are doing in AWS. The way to do it in AWS is like this, right? It is nothing special in AWS or different. It is just we are doing it in we are doing it in the cloud instead of the physical network. So anywhere we should not open, we should not put 000. The only place probably where you will put 00 is if you are exposing something like HTTP traffic or HTTPS. You are hosting a website and people need to access it from around the world. Then probably you have to open 000, but only for HTTP and HTTPS. Right? So this is the basic the normal how the traffic flows, right? Within the VPC, right? Within subnet. So even if you have two machines in the same subnet, they will not be able to talk to each other. If their security group ports don't allow the traffic. So because in the same LAN, people will think they should be able to ping or they should be able to connect. No, it will not work. Because each machine has a security group, and only if the inbound and outbound rules, appropriate rules are allowed, will the communication happen. What happens is they can talk over the private IP. They don't need to use the public IP. All machines in the same VPC, right? This private and public subnets are in the same VPC, are in our dev VPC. So what we mean by they can talk to each other means they can talk to each other over the private IP. They don't need to use the public IP. Public IP is used for communication when it comes from outside, right? Or traffic needs to go to the outside world, then it needs a public IP. Right? So how are you able to access the internet from your home? Because you have a public IP, you have an internet connection. That is why you are able to go to the internet. If I remove the ISP line, only the LAN part of your network will work. You cannot go to the outside world. Same thing here. Here, how the traffic is sent to the outside world, or how traffic is accepted from the outside world, it is because of the internet gateway. Right? How we were able to come inside to this machine was because of the internet gateway. Okay. Now I am in the private machine. Okay, so let me come out of the private machine. Okay, I showed you from the public machine accessing the internet, right? I opened port HTTP and all that. Now I'm in the private machine. So now from the private machine, I want to access the outside world. So somehow I logged into the machine in the private subnet. So now from the private subnet, I'm going to go to the outside world. I'm going to ping Google data. So ping is not working. So why is ping not working?
Outbound is not different.
Okay, so let us go and check outbound. So here you see outbound, all traffic is allowed.
The internet gateway is not set.
So the machines in the private subnet, they cannot go to the outside world. Even if you open all outbound traffic will not go out. All outbound means it includes ping. Okay. Inbound SSH is working because I opened inbound SSH. Okay, for the private machine. So let me just update this to anywhere for now. Okay. So I am able to access 1.86 to the machine in the public subnet. Okay, so maybe 1.86 is the DB server. So somebody needs to connect to the DB server. Your DBN needs to connect to the DB server. So he connects to the jump box. Let us assume 0.118 is the jump box. So from 118 he connects. Then from 118 he SSH into 1.86. Now from 1.86 he wants to access the internet. Maybe he wants to update the patches on the DB server or something. But traffic is not going, right? Say he wants to install some packages on the DB server or something, right? I'm just trying to install HTTPD, but something is he just needs to go outside and get some stuff, but it is not going. So it will not go because there is no internet gateway. There is no path to the outside world. There is no path to the, so this subnet is associated to a route table, right? This is associated to this route table. This route table has only the local route, so traffic will work only locally. And when it will work locally, provided the security groups are allowing. But there is no path to the outside world, so traffic will not go out. Traffic will not come in straight away, or traffic will not go outside also, even if it has.
And see that on query here.
Yeah.
Yeah. So like you told before, right? If we add this internet gateway to the private one, so then it will be a public, right?
Yes. This is private. The reason it is private is because it does not have a route to the internet gateway. If you add a route to the internet gateway, it becomes private. So the next question is how to
Correct.
keep it private, and I want to access internet. We know how to come in now. We found a way to come in. Now I want to go out. Right? Or do you want me to do anything else and show you?
We have to enable ICMP in the
No.
outbound.
Outbound I opened everything. All traffic means everything is allowed. Everybody go out. I am not stopping anything. Right? All traffic, all protocol, all range, everywhere. That means it includes everything. A to Z, all traffic is allowed to go out. But it is not going out. Okay, here not just ICMP, I opened everything. Okay, all traffic means everything. ICMP, HTTP, HTTPS, TCP, UDP, ports 0 to 65,565, go anywhere you want. But still traffic is not going out. From 1.86, I am able to connect to 1.86, but from 1.86, I am not able to go outside. Maybe I can go to the other machine. I can go within the VPC. But to the outside world, it's not going. Why it's not going? Because it does not have a path to go. Right? So this subnet, right, private subnet is associated to this route table. So all the machines in this subnet will follow these rules. So here there is no path. Here only a local path is there. That is why you are able to do this. You are able to talk between the machines in the same VPC across the subnets, because everything is 10.0.0.16. It is just a part of your VPC. But now the machine over here, it wants to go outside. Go outside for what? Like I said, you want to update the patches on the DB server, or whenever you take a DB backup, you want to trigger a mail that goes outside to the outside world, that is to outside your VPC. So how does it go? It cannot go now because there is no path for it. If you look at the route table for the private subnet, right? Let me open the route tables in a new tab. Right? If you look at the route table, it has only the local route. It does not know how to reach the internet. But here now, if I go edit routes and I say 0.0.0/0 and I say internet gateway, then what happens? Now traffic will
That's
go.
like public.
Now traffic will go. But what
Public.
happens? Our subnet become a public subnet. You should not do
Public.
this. You can edit the route table anytime. Right? It will work. But you should not do that. If it is supposed to be a private subnet, it is supposed to be a private. You should not. If you add this internet gateway rule, it becomes public subnet. It's just based on that rule. That rule can be modified anytime. So you should not do that. So how can you send this machine outside? So it needs to access the outside. Right? Now you see it will not work. I have removed the internet gateway rule. So how do you access the internet at home? You have a Wi-Fi router.
Port forwarding or something like that.
Yeah. So how do you do it at home? You have your LAN, right? Your machines. You have the Wi-Fi router, and then you have a ISP connection. So what is this Wi-Fi router actually doing? It is doing something called NAT. It is network address translation. That is, it is enabling you to basically share the single internet connection. That is, your machines are in the private side, but they are, all these machines have only private IPs, right? But how are they able to access the internet? Because your ISP gives you a public IP, which sits on the other side, which I told you is the WAN side, right? It is connected on the WAN side. So what this Wi-Fi router is actually doing, it is not doing any core routing as such, but we still call it a router. But what it is doing is network address translation. That is, it is letting you share this public IP. So this is what, suppose you're accessing google.com. So what google.com will see, it will see that the traffic is coming from this public IP. It will not see your machine's IP as such generally. So all that is handled by something called NAT, network address translation. So this Wi-Fi router will do NAT. So basically it will maintain a table. It will have the something like what do you say? Let me try it probably bigger. So all this is in general what do you say? Core networking, not only in AWS, anywhere. What happened? Right. So this Wi-Fi router or any NAT device, what it will do is it will have something like a table, right? Where it will have the source IP, right? Source port, destination IP, destination port. So each machine in your LAN will have an IP like 1.100, 1.101. So whenever you're accessing internet, suppose if both the people are going to gmail.com, you are also going to Gmail. This guy is also going to Gmail. Both go to the same Gmail, right? So how does it know which packet to come back to whom? Because you are on the private network. So what happens whenever you are sending a packet, the what do you say, traffic, the Wi-Fi router will not know. Okay, source IP is 100. So whenever you open a connection, a random port is opened in the background, right? Whenever you open your browser, you are not going out on port 80. You are hitting port 80 for Google, right? On your machine, you are not using port 80. Depending upon the OS, a random port will be opened, right? So here, if you see, some ports are open, right? 139, right? Port numbers are 1265536. So depending upon what I am trying to access, right? So if I'm opening a browser and opening some page, so it will randomly open an IP. Those are called ephemeral ports, right? So my source IP is 103. My source port is 58558 for this particular traffic, right? So like that, the destination is what? It is going to some server, right? So what is this? This is probably my SSH connection, right? If you see this, right? Here you see, this is the SSH connection for this machine which I made, right? My public machine, 997950 So you see that over here, right? You see this, right? My source IP is, that is my laptop's private IP is 0.103. What is the port it is using? 58347. That is the port that is open on my machine to connect to SSH. I am not opening SSH on my laptop. My laptop will choose a random port to connect to 9979 on SSH. So you have the source IP, source port, the destination IP, the destination port, depending on what you are accessing. So your laptop will open a random port for every connection you are making. So this table is maintained in the router. That is what is that. So I'm saying my source IP is 100. My source port is something 5858. The destination IP is whatever is the IP, right, of my server. This is the 99, and what is the port? 22. So when the reply comes from this, it will come back to my machine. It will not go to other people, because this router is doing that work. Your router is basically doing this work. It is mapping. It is keeping a continuous map, because multiple people are sharing the same IP. How is it going to be unique? It is because of the ports. It is because of the combination of the source IP, source port. It will not be the same. The port may be the same, but the source IP will be different. If somebody else is accessing Gmail, his OS also might open the same port. His browser might open the use the same port 58, but his source IP is different. So his packets will go to him, your packets will come to you, right? Which is why you are able to share the internet connection, right? Your Wi-Fi router is actually doing that. That is network address translation. It is translating your private IPs to public IPs, sending the traffic out. It is getting the reply. Google will reply to your router, not to you. It will reply to the router. The router forwards the packets to the corresponding client based on its table. Who sent it? It will make a note. It will send the reply back to them. That's what is happening. So here also in AWS, you need to do something like this. This is for the machines in the private subnet. For the machines in the public subnet, you are straight away giving them internet connection, right? The machines in the public subnet are straight away able to access the internet through the internet gateway. So think of the internet gateway like as if the machines are straight away connected to the ISP's line. Say you have a camera at home, right? Maybe nowadays you get an app and all that, but still, if you have a CCTV camera and you want to access it from anywhere in the world, then you might need to give it a public IP. Maybe a direct connection from your ISP will be connected to the camera, public IP, so that it can be accessed from anywhere in the world. But nowadays, using dynamic DNS and all that stuff, you can put it in the private network and still be able to access it if you map it to a static DNS name or something. That's what all these apps do, right? But in general, if you don't want to do all that, you can directly connect it. You can get a public IP from your ISP, straight away connect it, open its port, whatever it is, and you have the IP and the port to access the camera, and you have its it will have some login credentials. You can log in and watch the feed, right? So it is like in the public subnet, but at your home, what you have technically a private subnet with a device which is doing NAT, and your ISP is providing the connection to the NAT device. This is doing the NAT so that all the devices behind this can access the internet. Same thing is probably happening in your office, right? All your machines don't have public IPs. The public IP they will connect it to their router, where they will do NAT and they will share the internet connection. So everybody is able to access the internet. Okay. So the machines in the private subnet are something like this, right? So in order for them to access the internet, you need to put something called the NAT or NAT gateway. You need a device which is doing NAT. You have two options for that. One is a NAT gateway, one is a NAT instance. NAT instance is the old type. Nobody really uses this anymore, but it is still available, right? A NAT gateway is a fully managed service. So at your home, how can you share the internet connection? You need something which is doing that, right? At your home, you basically need some device that is doing that. What is the easiest way is to buy a Wi-Fi router and plug it in. It does not have much setting, right? You just need to put your ISP provided credentials and it is going to work. You are not doing anything for NAT. So this Wi-Fi router its main duty is to do that. It is pre-configured for that. You don't install any software or anything on the router, right? You just configure your LAN side or the wireless password you put and you're done, right? What is the other way you can share internet connection? So at your home, you can put a PC. It can have some, like you said, like a virtual firewall software which does that. Probably at your office, they will not use a small Wi-Fi router, right? They will have a bigger device which can do multiple things, right? So at your home also you can do this. You can put a PC. If you have an old PC, you can put an old PC. You can have two interface cards, two NICs, one connected to the ISP, one connected to a switch at the back end. The switch, all your machines will be connected to this, right? And then you configure the NAT over here. Still all your machines will be able to access the internet, everything will do, but it is complicated, right? You have to have a PC which should always be on. It will have OS. You have to configure the software, all that stuff. What is easier for us? You buy a device which is out of the box, you plug it in, it will work, right? So AWS also has two ways you can do that. One is using a NAT instance, NAT gateway. NAT gateway came after NAT instance. So now everybody uses NAT gateway. I don't think anybody really uses NAT instance, but I'll show you both how to configure both, right? Because earlier means around until 3 years ago, right? Uh, like I said, for NAT you have two types of devices. One is NAT gateway, NAT instance. So earlier NAT gateway was not available in all locations. Like I said, all AWS services are not available in all locations. Okay, so earlier NAT gateway was not available in all locations. So in some cases we had to use NAT instances. So prior to NAT gateway, only NAT instance was there. NAT gateway came, I think, around 2014 or 15. Okay, NAT instances have been since the beginning of VPC. Okay, so NAT gateways came after this, and even when it came, it was not available in all locations. So as late as 2017, late 2017 or early 2018, NAT gateway was not available in all locations, right? Because we assumed for a project that NAT gateway will be available because it came around 2014 or something, and 2018, 2017 ending, there was a project in the Cloud, which is a separate region, which we have never used. We used other regions, right? We use US East, right? Mumbai and all that stuff. So some government project was there, so we had to use the Cloud. They gave us access to the Cloud. So we are creating the VPC. The first thing is you create the VPC, right? You create the VPC and all the subnets, the NAT and all that stuff you create. So the NAT gateway was not getting created because we don't use the GUI, we use the command line. That is, we use infrastructure as code. But for that you have to know the GUI, right? So we create this infrastructure using a configuration file, right? We create that infrastructure using a configuration file. Maybe I'll show you that. So we will see this towards the end of the course, not now. You should know how to do it manually first. Then we can automate it, right? So here, for example, something like this. We will use this of code to create our infrastructure, right? So the VPC and all that you can create using a configuration file like this. Instead of manually going and saying create a security group, open the port, it can be specified as a configuration file. Okay, which is what a lot of people in real time do, right? You are not going to manually do it from the GUI. Okay, so when we created this configuration file and we deployed it, it was not being created. It was failing. Why it was failing? Then we went and checked. There was a problem while creating the NAT gateway. Okay, we specified it as a NAT gateway and created it. We configured it. We copy pasted. Create means copy paste from some other infrastructure. Just change the values, copy paste. It was failing at the NAT gateway. It was giving error. Then we went and checked inside. Then we realized that in the US Cloud there is no NAT gateway. NAT gateway service is not available in the Cloud. We assume that it will be there because it is probably 99% of the people will have NAT, the VPC. Right, so we assume NAT gateway is there because it came in 2014, already 4 years over. It will be there. It is a 100% of the people are going to use it, but it is not there in the Cloud. Then we checked the documentation. We realized NAT gateway is not available in the Cloud. You have to use NAT instance. So you should not assume that some service is there. Whatever we want, first we have to check whether in that region it is there. So in that case, what we had to do, we had to use the NAT instance. After using the NAT instance, after 2 months, they launched the NAT gateway in GoPro. Our bad luck, we had to again replace the instance with the gateway because the gateway is better. But while creating, it was not there. After we created the project, after it went live correctly after a month or so, the NAT gateway was introduced in the Cloud. Now I think it is there in all regions, but still we should not assume. We should check because I have not checked all the regions. But as far as I know, I think it is still available. Now it is available in all regions.
Okay. So that one clarification here. Yeah. So since you told that in the real time, all this will be configured in the code, right? It's not through GUI?
Mostly no. Big companies no. Some of them
it's only code. Huh?
Mostly it is code.
Okay.
Mostly it will be code. Sometimes it might be through GUI. Earlier it was mostly through GUI, but now past 2-3 years, a lot of people are using code. But to use that, you should know what is what. Simply you can't just go and create the configuration file. You should know what are the properties you have to give and all that stuff, right? So security group means inbound, outbound rules. So all this we have templates. So you just have to know copy paste which to edit. It is not any programming language. Okay, so some people get scared. Okay, it is simply like a configuration file. That's all. Right now it is possible to do using programming also. Very recently AWS has launched that you can create infrastructure using your programming language also. Right, we are not going to go into those things, right? But we will see infrastructure as code, that is cloud formation. AWS has a service, their own service called cloud formation, right? Cloud formation is to create and manage the resources with templates, that is programmatic or infrastructure as code. Even though they say code, it is a configuration file. It is not any Java or PHP, right? It is a what do you say? It is in YAML or JSON format. It is basically a configuration file. If you go through a few configuration files, you will get a hang of it. But you should know what to create. That is, you should have this architecture diagram. Without the diagram, you cannot what do you say? Create that configuration file. So you should know, okay, we have two VPCs, two subnets, two machines. So you go and you copy the segment for, suppose I want to create a security group. So I will just copy this part, right? This part of it creates a security group. If I want another security group, what I will do? I will simply paste it here, change the security group name and change the rules. That's all. It is copy paste. Okay, you should know what you want. You take that segment, you put it, you change the values. Done. Okay, so don't think I typed 392 lines. It is copy paste and change the values. Okay, so the main thing is you should know which value to change. So what does each segment mean? Right, but for that you should know what is a security group, what is inbound rule, what is the ports, all that stuff. Right, so all that you learn from the GUI, and then you can what do you say, learn the programmatic way, that is infrastructure as code. Okay, so we will see this towards the end, 3-4 classes, infrastructure as code. In the exam, you will not get any questions for you to create or anything in the architect exam. Architect exam, you will not get all this. All this is DevOps level or practical level. Okay. So we will see a little bit of infrastructure as code also. Okay. But for that, you should practice in the GUI first. Otherwise, you will not know what is where, what are the options that we have to set. Because in the GUI, it is easy. You can look and you can see and do. But in the template, you have to specify everything. You cannot assume, right? In the GUI, while creating the machine, it will, what you say, it will ask you to choose the security group. It comes in the wizard. But here in the configuration file, you have to specify that value. If you don't specify, it will fail. Right? If you don't specify the value, it will fail. In the GUI, you specify the value because it makes you specify the value. Here, it does not make you. Whatever you put, it will try to do. If that value is not there, it will give error. So here, I'm creating an instance. So instance means it has certain properties. Certain properties compulsory you have to give. If you don't give the property, the instance will not be created. So those how you will remember only if you know how to do in the GUI. But the GUI, you are forced to choose the AMI, right? You have to choose the instance type because it comes step by step. But in program, in code, you put everything in a single line. So if you don't specify the instance type, you may get an error, right? So yeah, okay. So we will see that infrastructure as code also later on. But the next week we will continue with the VPC, right? So for now, maybe you can just try to create at least the VPC and the subnets. The same thing is there in the VPC user guide. I told you, right? You can go to VPC user guide. You don't worry about the instances for now. I just hope you're able to understand the traffic flow, right? You can create the VPC and the subnets because it is free. So now, so far, whatever we have seen, it is free except for the instances. Instances cost money. So you can go through these couple of things, right? What is VPC? What is subnet? You can go to the getting started, right? Here you have a VPC with a public and private subnet. This is what we are doing, right? This is what we are doing. So you can keep this diagram. You can just try to create the VPC, create the subnets, right? And update the route tables. You don't have to launch instances. Just at least so much you can check. this is going to be the most common architecture, right? People will have at least one VPC, at least one public, one private. If you want more, it is more. The steps are the same. We have just created with one. So in real time, you might have three public, three private subnets, two VPCs. We will see that also. We will create multiple VPCs. We will see how to interconnect two VPCs, VPC peering. You will see those things also. But for now, maybe you can take this diagram. This is what I have also shown, right? You can take this diagram, try to create the VPC. You can use different CIDR apart from this. If you want, you can try different IP addressing because you may not be familiar with IP addressing. So just get a hang of it, right? So try to create the VPCs. They don't cost any money. After you finish practicing, what you do, because you are not going to launch any instances, right? So how do you clean up? You can just remove the VPC. It will remove everything that you created, right? So you are not going to create instances, so no problem. You can just remove the VPC. I will not remove the VPC because again next class I have to show you, right? So say for example I'm in some other region in Frankfurt or something. Just like how you remove the default VPC, you can remove this VPC also. It will remove everything which are associated with that, right? Just like how you can go to the VPC in any other region and you can remove it, right? You can just choose the VPC and say delete, right? You can choose VPC and say delete VPC. It will delete the VPC, or maybe I will delete it next week. We will recreate it. What is the VPC, right? Okay. So after you finish practicing, you can say delete VPC. If there are any dependencies, it will give you an error. That is, if you have any instances or anything, it will give you. Otherwise, it will say deleting this VPC will delete all the subnets, security group, access control list, internet gateways. These are the four things that you will probably have, and the route tables. Everything will be deleted. You clean up. If you get confused, you are stuck somewhere, you delete everything, again create, because it is free. It's not only free tier, it is free. VPC is free. Okay, I mean these components are free. All components are not free. VPC, subnet, route table, security group, access control list, they are free. Okay. So in the next class, what we will see is when is the next class for us? It is going to be on September 19th. I'm just making a note of it because I have other batches also. On September 19th, we will be talking about security group versus network access control list. We're talking about NAT gateway, NAT instance, right? And then we have a few other topics in VPC, like we saw Bastion host. Direct connect, I think I explained yesterday what is direct connect. We cannot establish a direct connection, right? Yeah, we need to talk about VPC peering. I'm just noting down the topics, right? So VPC peering, VPC endpoints, maybe a little bit about VPN connections. So let's talk about high level, and then we have VPC flow logs. This also we need to VPC flow logs. So these are some of the remaining stuff. Okay, so we will cover these things over the next couple of classes. Okay. Meanwhile, in between,
Okay,
if
sir.
you have any questions, you can just let me know. If you are stuck somewhere or something, you can just ping me on WhatsApp with a screenshot or something, whatever error you are trying to do. You can try to help. Okay.
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 And do share some questions, Siddharth, like
Yes.
for exam point of view.
Yeah. Tomorrow, today is Sunday. Yeah. Tomorrow morning I'll share it because I'm just collecting some new questions and putting it because the old exam is
Okay.
retired. So the new one I will just update it and send you with respect to S3 and the VPC.
Okay. Okay. Sure.